x raised to the power 2021 plus x raised to the power 2020 plus and so on up to x minus 1 equal to 0. Then all real roots are positive. Exactly one real root is positive. Exactly one real root is negative, and no real root is positive. So this problem is related to roots and how many roots, either and nature of the root. So problem is related to roots, either positive or negative, and how many existence. These are few terms related to this problem. So how to solve this problem? So Descartes' rule of sign change can tell us how many real roots or real positive or real negative root for this polynomial, because of, you can say this is a polynomial structure of the equation. So how many roots will exist according to Descartes rule, we can easily find out. So first, what is the Descartes rule of sign change? Tell us. It is a technique for getting information on the number of positive real roots of a polynomial. By using the transformation x2 minus x, we can easily tell about how many negative rule of polynomial exist. So what is the geometrical meaning or geometrical interpretation of the root? Geometrical interpretation of the root tell us x-axis intercept, means at how many places x-axis intercept. These are the meaning, or this is the meaning of root existence. Also a very commonly used theorem in a real analysis we study about root. This is IVT, or intermediate value theorem. This says if a function f is continuous on domain, continuous over domain, and function is also continuous inside the interval or inside the domain and in this interval, then there exists a C such that before this a condition on hypothesis is that if f of a and f of b, product of these two endpoints of the interval, if product of this is negative, then there exists a C between a and b such that fc is 0. What it's a geometric meaning. Suppose this is the graph of the function, means going negative to positive either in increasing way or in decreasing way. So if negative to positive or positive to negative, either in concave up or concave down, we can say there exists a C lies between a and b such that this C is the root of the polynomial. So this is the meaning, geometric meaning of intermediate value theorem. And this is a corollary normally known as Bolzano theorem about the roots. If f of a, f of b is less than 0, means at the end point of the interval, means the image of the endpoints of the interval is a negative product of the image, then there exists a real root. This is normally known as Bolzano theorem. And the second thing is about the image of the endpoints. The image of the continuous function over an interval is itself an interval. This is image of continuous function over an interval is again an interval. This is second corollary you can study here. So as you can see, at a and b, these are 2 points normally we use in intermediate value theorem. So because structure of the polynomial is like this, x raised to the power 2021, x raised to the power 2020, plus and so on up to x minus 1. This is the structure. So you can say this is the polynomial px, or you can say fx. So normally when we check what are real roots of the polynomial, so normally or sometimes we put 1 minus 1 and 0, because of these are very elementary points, and calculation over these points is very easy, so we can try to find or judge these are the root or not. So value of f0 will equal to minus 1, because of other terms minus 1 will go to 0. Value of f1 will be up to here, you can see positive value and minus 1. So means there are 2021 terms. So 2021 minus 1 will equal to 2020. So this is the value of f1, and value of f at minus 1 will be, you can see up to this there are 2020 terms, means 2020 terms. So one is positive and other is alternative positive and negative, so all will cancel out and remaining one will be these. So value of x minus 1 means after putting minus 1 will equal to minus 2. So value of f minus 1 is minus 2. So we have f0 is minus 1, means negative, and f1 is equal to 2020. So this is positive value. As I already told about geometric interpretation of the intermediate value theorem, one is positive and negative, so you can say f0 and f1 is negative. Product of these two is less than 0. So using by IVT or intermediate value theorem, we can say there exists a C lies between 0 and 1 such that Fc is 0. So existence of the root comes from IVT. But how many roots will exist? So it is at least, not at most. At least a C belongs in open interval 0 1 such that fc is equal to 0. But how many? The answer of this problem we can solve using Descartes rules of sign. As x raised to the power 2021 plus and so on up to x minus 1, there is only, because we are seeking over interval 0 to 1, so there is only positive real root. There is only positive real root because of only one sign change, positive to negative. So only one, and you can see 1 to infinity means over this interval or x greater than 1. So value of these terms, value of these term will be positive, will be positive, and how much? It will be 2021 minus 1. So entire value we will get a positive value. So means there is no point where fa fb is less than 0. So there is no real root in the interval 1 to infinity, means there is no existence of the root. And you can see minus infinity to 0, you can find how many real root exist. But you can see we have solved this problem. No real root is positive, but real root is positive, real root is existing by Descartes rule. So this option is false. All roots are positive. We will come on this option A. Before Solving this, exactly one real root is positive. So this is true. Exactly one real root is negative. So solving this, exactly one real root is negative, apply Descartes rules. So we can see that after changing x or transformation x to minus x, we seen that up to x raised to the power 2021 and so on up to x raised to the power 3. Up to here, there are 20 terms. So one is negative, means alternate negative positive, and this is even. So half is positive and half is negative, so entire will cancel out. So value will depends on x minus 1, means after putting x to minus 1, so you can see value of this is negative, means there is no sign change because of after applying this transformation x to minus x. So minus x minus 1, so there is no sign change. So we can see that exactly no real root is negative. So this option is false. All means only and only one real root exists and this is positive, means all real roots are positive. So option A is also true.